In this video, I want to remind you that SNAP uses the following relational operators: less than, greater than, and equal to. Relational operators are used to make a test for an if statement. We've seen that before. If answer is greater than 95, say great job, else say keep working. That's a relational operator. It allows us to make a simple test. Now we can combine two simple tests, two relational tests together using a logical operator. Say and or. And is a logical operator where both the surrounding tests need to be true for the if to be considered true. Or is a logical operator where just one of the surrounding tests need to be true for the if to be true. So if answer is less than 0 or greater than 100, if either one of these is true, then the if is true. I'm going to say bad data. If both of these in fact are false, then I'm going to get to the else and say good data. So in other words, if just one of these is true, it's the answer is less than 0 or the answer is greater than 100, I have bad data. Now I can reverse this test. If answer is greater than -1 and answer is less than 101, if both of these are true, I have good data, else I have bad data. So and says that both of these need to be true in order for the if to be true, and or says that just one of them needs to be true. Now we're going to go here and take a look at this. Ask, enter a score, and wait. And I am going to say 56. Good data, continue processing. So 56 was not less than 0, or 56 was not greater than 100. This failed. Else, good data. So now I'm going to say, let's do this one again. I'm going to say -2, bad data, because -2 is less than 0. Or, so just one of these needs to be true. Minus true is less than 0. That's true. Or, and what you have here is a situation where just one of these is true and the if is true. Now, here in this case here, both these need to be true. So I'm going to say 56, good data. Is 56 greater than 0? Yeah. And is 56 less than 100? Yeah. Good data. Both those are true. If I do it again and I say -2, is -2 greater than 0? No, it's false. False and, well, this if must be false. Bad data. Okay, now I do want to see if I can pull one more thing up for you. And I was working, let's see if I can find it real quick. Here it is. Down here at the bottom I have a logic table. Okay, let's talk about P and Q. So I have some different scenarios for P and Q down here. So if P is true and Q is true, P and Q is true. P or Q would be true. If P is true and Q is false, P and Q is false, but P or Q would be true. If P is false and Q is true, P and Q would be false, but P or Q would be true. And if P is false and Q is false, P and Q would be false, and by the way, P or Q would be false. I better fix that. So this is a simple logic table. Take a look at it, study it, and hopefully it helps. We will do more on this logic in the next module.